Hello and welcome to this video about volume of spheres and cones. The learning target for this video is to find the volume of spheres and cones, as the title would imply. So this one is fairly straightforward in that it's all about just kind of knowing the formula. I'm not going to get too much into the why of the formula because that makes things pretty complicated pretty quickly. But keep in mind that this is in the unit about geometry with circles in it, and so spheres and cones, they have circles in it, therefore it's something we should probably be familiar with. So anyways, if we take a look at sphere, the formula that we need for this, volume is equal to 4/3 pi r cubed. Now we got a couple little details here. We have the 4/3 and we have the cube. So these are just these things. Well, the cube makes sense because we're talking about volume. So we have that third dimension. So it makes sense that, we care about the radius as it's going in all three dimensions, those three different directions. The 4/3, that's where, again, it's a little more complicated. So let's just accept it for what it is and be able to use the formula. So first example, real simple. Let's say that the radius is equal to 5, and we want to find the volume. Well, just plug it into the formula. V is equal to 4/3 pi 5 to the third power. So that gives us V is equal to 4/3 pi times 125. See if we can cancel anything, and if we can't, we can just move on to multiplying 4 times 125. And so V or the volume is equal to 500 pi over 3. And if we wanted to, we could leave that as an exact answer, or we could times it by 3.14 and then do the division of 3 and say it is roughly equal to 523.3 repeating, and both of these would be in units cubed. So keep in mind, your units have to be cubed at the end. And again, we have the exact answer with pi, or we can use an estimate, 3.14, and do it that way. Now, I just want to point out one thing. Let's do another quick example. Let's say that the radius is equal to something like 9. Well, when we go to plug that in, we're going to get V is equal to 4/3 pi 9 to the third power. Well, that means V is equal to 4/3 pi times 729. Now, sometimes if this guy is a multiple of 3, this 3 will cancel out with it. So 729 is divisible by 3. And when we do that, 729 divided by 3, so one more time, 729 divided by 3, we end up getting 243. So every now and then the third will go away. So we have 4 pi times 243, times that by 4, and here our exact answer would be 972 pi units to the third. So just be mindful of that. If you have a multiple of 3, your 1/3 will disappear. All right, next, let's take a look at cones. So cones, kind of a similar thing where it's just helpful to know the formula. And let's also kind of talk about the different pieces we have to a cone. So we have the circle that's in the bottom, and so you definitely have your radius, but then the other thing that we have here is the height of our cone. And I wanted to draw these two just to kind of show you that, sometimes, our cones could look maybe a little bit different than that standard image that we have in our mind. So we could have a cone where the radius is perhaps a lot bigger than the height. And then we could obviously have one where it is the height's bigger than the radius. And we could have ones where they even match up. All right, so just kind of try not to let a predetermined image kind of, shape the way you attack the problem. Now, one of the core ideas we have with volume is that volume is simply the base area, so the area of this circle times by that third dimension, the height. But the thing is, since it goes together at a point, we have to make a small adjustment. So our volume formula is going to be that base area, pi r squared times height, but we're going to times it by 1/3. Or you can think of it as dividing by 3 if you want. And that's how we find the volume of a cone. In fact, anything that comes together at a point is has that 1/3 coefficient to it. So again, if we do a couple of examples, so let's say that we have the radius is equal to 6 and a height that is equal to 5. Let's see what we end up getting for our answer. So I plug it in. So V is equal to 1/3 pi times 6 squared times 5. Now, it really matters where we put our things into the expression, and it also matters that we do order of operations. So I'm going to go 1/3 times pi times 36 times 5. I'm not going to jump the gun and try to cancel out the 1/3 and the 6. Now, these guys can get canceled out, and that's going to give me 12 pi times 5, which would equal 60 pi. And so it's 60 pi units to the third if I'm being exact. Or if I wanted to, I could times 60 by 3.14 and get 188.4 units to the third if I'm using an estimate like that. To do another example, let's now use some decimals, make things maybe a little more adventurous. Let's say that our radius is equal to 0.8 and our height is equal to 1.4. Again, nothing really changes. We plug those values into our formula. So we'll have 1/3 pi. Okay, make sure you're putting the numbers in the right spot. So 0.8 is the one that's the radius, so that's squared. And my height is 1.4. So go about squaring 0.8, and that ends up giving me 0.64. So I have 1/3 pi, and then 0.64 times 1.4. So times that by 1.4, oops, 1.4. And I have 1/3 pi times 0.896. So divide that by 3. And my exact, well, this is where it's getting kind of weird. Like my exact answer is just really funky. So I'm actually going to do the division actually times it by pi. So times by 3.14. And so yeah, use it all in decimals. And so I get 0.9378, which would roughly round to 0.94 units to the third if I were to use an estimate for pi there. All right, very good. So that's it with cones. Now we got to keep in mind the last thing, which is that we may be expected to work backwards. So again, it's handy to keep in mind the volume of a sphere, that formula. So that is 4/3 pi r to the third, and the volume of a cone, which is 1/3 pi r squared times our height. So in number 1 here, we have the volume of the volume of the sphere is 113.04 inches cubed. Find the radius. Well, 113.04 is equal to 4/3 pi r to the third. First thing I'm going to do is I'm going to times both sides by 3/4. And the reason why I do that is because of this 4/3. That 3/4 makes that go away. And so now I have 113.04 times 3/4. That gives me 84.78. And that is equal to pi r to the third. Well, now I'm going to divide both sides by pi. And when I use my calculator to do this division, I'm going to use 3.14 as my estimate there. And I have r to the third is equal to 27. At this point in time, I need to think what number to the third power is 27. Technically, what I got to do is take a cube root. And if you want to, you could use your calculator to do that. And it's going to tell you that r is equal to 3. Now, let's compare and contrast that. Oh, sorry, I should finish that off. 3 inches. All right, let's compare and contrast that to number 2, because it's very similar. Number 2, volume of sphere is 288 pi centimeters cubed. Well, 288 is equal to 4/3 pi r to the third. Just like the last one, 288 pi. Just like the last one, I'm going to times by 3/4, times it by 3/4. So 288 times 3/4 gives me 216 pi. There we go. Is equal to pi r to the third. Just like the previous problem, I'm going to divide by pi. But this time I'm not using 3.14. Those pi's cancel each other out. And so I have 216 is equal to r to the third power. Want to, I could use the calculator to take what's called the cube root, or again, ask myself what times itself 3 times is 216, and that's going to be 6. So that one is 6 centimeters. So that's how we do those sphere problems. Give me 1 second here. Let me clean that up. And then we can take a look at how we would do the cone problems. Now, cone problems, we have to be careful. We have two variables. Keep in mind, we have the R and we have the H. So we're going to do the same thing where we plug in the volume, plug in the information we have, and try to solve what we don't have. So for the first one, I'm given that the volume is equal to 401.92, and that is equal to 1/3 pi, and I'm given the radius 4 squared, and then times h. And I'm trying to find h. So a couple ways you can go about it. One, I don't like the fractions. So right off the bat, I'm going to times everything by 3, so that way it's just out of my way, and I don't have to worry about it anymore. So I times that by 3, I have 1205.76 is equal to pi. And then I'm going to multiply this out, 16h. Now, if I want to, I can divide by the 16 pi, or 16 times 3.14. So divide that by 16, divide by 3.14. You can do it in 2 steps, you can do it in 1 step, however you want. But then that gives me h is equal to 24 inches. All right. And then finally, number 4, if the find the radius of a cone if the volume is 252 pi is equal to 1/3 pi. We don't know what r is, and then h is 7. So again, what I'm going to do first thing is get rid of that fraction because fractions can make things tricky. 252 times 3, that is 756 pi, is now equal to pi or 7 pi r squared. So I just took that 7 and I moved it to this side because the 3 and the 1/3 canceled each other out. Divide both sides by 7. Divide by 7. So I now have 108 pi is equal to pi r squared. And so divide both sides by pi, divide by pi, that goes away, that goes away. And so now, last thing I need to do is take the square root of 108. So r squared is equal to 108. 2 ways we can do it. We can leave it as an exact answer, so r is equal to the square root of 108, or we could also get a decimal approximate for what that is, and that would be, wait for it, r is roughly equal to 10.4, if we were to do it that way. So when we're dealing with pi and we're dealing with circles, our answers might not always be perfectly clean. And so that was the point of that problem right there. But what it boils down to for the volume of spheres and cones is just knowing these formulas up here. As long as we know those, we're good to go. We could either find the volume or we could use the volume to find a different dimension. Good luck with your homework or practice, and let me know if you have any questions.